So, let's go. Number 1, you are already spinning. Right now, you think you're sitting still. You're not. You are moving in 3 different circles at once, and you can't feel a single one of them. Start with the ground under you. If you're anywhere near the equator, that ground is carrying you east at about 1,040 miles an hour. Faster than a passenger jet. Your coffee doesn't even ripple. That's Earth turning on its axis, and it's been doing it since before there was a you, before there was a coffee, before there was anyone to be surprised by it. Now zoom out. That whole spinning planet is also falling in a giant loop around the sun, and it's doing that at about 30 kilometers every second. Not every hour, every second. In the time it took you to read that sentence, you traveled a few hundred miles and arrived nowhere, because the sun moved too. And it gets worse. The sun isn't sitting still either. It's dragging you and Earth and everything you've ever loved around the center of the galaxy at roughly 500,000 miles an hour. You are on a carousel, bolted to a much bigger carousel, and every layer is turning. Here's the part that should bother you. You feel none of it. Not the 1,000 miles an hour, not the 30 kilometers a second, not the 500,000. Your body has no idea because steady spin is invisible from the inside. Your inner ear only notices when something speeds up or slows down or yanks you sideways. As long as the turning stays smooth, your brain files it under not moving and moves on. So you go about your day convinced you're a still thing in a still room. And the truth is, you have never once in your entire life been still. Not for a second. Not when you were sleeping. Not when you were holding your breath trying to be as motionless as possible. You were screaming through the galaxy the whole time. That's the small version. That's just you, on one planet, around one star, in one galaxy. The question this video is actually about is bigger and stranger than that. Because it's not just you that's spinning. It's the planet, and the star, and the galaxy, and the things galaxies are made of. And maybe, if a few scientists are right, the entire universe. Everything turns. Nothing rests. And once you understand why, you're going to have a very hard time believing in the idea of still ever again. Number 2, the rule that won't let anything stop. So why does everything spin? Not some things. Everything. Planets, stars, whole galaxies, all of it turning, all in the same universe, like they got the same memo. The answer is a single stubborn rule, and once you see it everywhere. It's called conservation of angular momentum, which is a heavy phrase for a very simple idea. Once something starts turning, the universe really does not want it to stop. You've watched this rule work with your own eyes. A figure skater goes into a spin with her arms out wide, then she pulls them in. And without pushing off anything, without any help, she suddenly whips around faster. She didn't add energy, she just moved her mass closer to the center. And the universe, to keep the books balanced, sped her up. That's the whole trick. Spin is a currency that can't be printed and can't be burned. It can only be moved around or squeezed. Pull the mass inward and the turning has to get faster to make up for it. Now do that with something the size of space. Take a cloud of gas light years across, drifting in the dark, barely turning at all, so slow you'd never notice. Then let gravity pull it inward, let it collapse. Shrink it down by a factor of 100, 1,000, more. That barely there spin has nowhere to go. It can't vanish. So it concentrates. And that lazy, sleepy rotation you could have ignored becomes a furious, howling spin by the time the cloud has shrunk into a star. The skater pulling her arms in, except the skater is a dying cloud the size of a solar system, and the spin at the end is violent. This is the key that unlocks the rest of the video. Nothing out there decided to spin, nothing chose it. Spin is just what happens when you take a little bit of turning, which every clump of gas in the universe has, and you crush it down under gravity. The rule does the rest, automatically, every time, with no exceptions. So when you look up and see spinning planets, and spinning stars, and spinning galaxies, and wonder how they all got the same idea, they didn't. They all obeyed the same law. A law that turns a whisper of rotation into a scream and never once lets it fall silent. Which raises a very uncomfortable question. If spin can't be destroyed, then every bit of it that exists right now came from somewhere, and that trail leads back further than you'd like. Number 3, the cloud that couldn't fall straight. Look at almost anything big in space and you'll notice something weird. It's flat, not round. Flat. Our solar system is a disk. The planets don't orbit in a random swarm all around the sun like bees. They ride in nearly the same plane, a thin, flat sheet, as if someone laid them on a table. Saturn's rings are flat. Galaxies, the huge ones, are flat too, great glowing plates of hundreds of billions of stars. Why? Why is the universe so obsessed with flatness? Because of the rule you just learned, and one small thing it does to falling gas. Picture that collapsing cloud again. It's got a tiny spin. Now gravity starts pulling everything toward the center. If you're a bit of gas sitting directly above or below the spin axis, nothing stops you. You fall straight in. Clean. But if you're a bit of gas out along the sides, out at the cloud's waist, you can't fall straight in. Your spin holds you up. You're circling too fast to just drop. So you stay out there, orbiting, while the top and bottom of the cloud keep collapsing inward. Do that everywhere at once and the cloud squashes. The poles cave in. The middle stays spread out. And a shapeless blob becomes a thin, spinning disk. Every single time, for the same reason. That's what you're looking at when you see a solar system laid out flat. You're seeing the fingerprint of spin. The flatness isn't decoration. It's evidence. It's the shape that rotation forces onto anything that collapses while it turns. And here's the quietly disturbing part. Our own planets, our own Earth, formed out of that flat disk around the young sun, the dust in that disk clumped into rocks, the rocks smashed into worlds, and each collision handed over a little more spin. Earth's daily rotation, the thing giving you sunrise and sunset, is a leftover. An echo of the exact tumble of the debris that built it billions of years ago, frozen in and still turning. You didn't get day and night because a planet decided to rotate for your convenience. You got them because the cloud that made the sun couldn't fall straight down, and everything born from that cloud inherited the swirl. So the flatness of the solar system, the spin of your planet, the length of your day, all of it traces back to one whisper of rotation in a cloud that no longer exists, which brings us to a spin that doesn't add up. One sitting right in the middle of everything. Number 4, the sun spins. Too slowly. Here's a number that keeps a certain kind of scientist awake. The sun holds 99.8% of all the mass in the solar system. Everything else, every planet, every moon, every asteroid and comet and speck of dust, all of it added together is a rounding error next to the sun. So the sun should own the spin too, right? It's the giant. It's basically everything. If spin follows mass, the sun should be twirling like mad. It isn't. The sun takes about 27 days to turn once. It's slow. Almost embarrassingly slow for something that big. And when you actually do the math, you find that the sun holds only a tiny sliver of the solar system's total spin. Most of it, something like 98%, is out in the planets. In the specks. In the rounding error. One planet, Jupiter, all by itself carries more than half of all the turning in the solar system. Jupiter. A ball of gas you could lose inside the sun 1,000 times over is out there hoarding the spin, while the giant in the middle barely moves. This has a name. Scientists call it the angular momentum problem, and problem is being polite. Because the rule you learned says, spin can't just disappear. If the sun formed from a collapsing cloud, the skater effect should have spun it up ferociously. It should be whipping around 100 times faster than it does. It should be a blur. So where did the sun's spin go? The leading answer is that the young sun cheated its own spin away. A newborn star is wrapped in magnetic field lines, and those lines reach out and grab the disk of gas around it, and the wind streaming off the star drags on them. Turn a magnet fast enough with stuff clinging to it, and the stuff pulls back. The sun, over millions of years, magnetically braked itself. It flung its spin outward into the disk and the planets and slowed down. Probably. It's the best story we have. But the numbers still don't line up cleanly, and if you ask the right astronomer, they'll admit the accounting is messy. There's spin missing, or spin hiding, or spin that went somewhere the models don't quite capture. And that's the thing about spin. Even here, in our own backyard, around the one star we understand best, it doesn't quite balance. It slips through the math like it has somewhere else to be. Now hold on to that feeling, because the next place spin shows up, it isn't moving objects at all. It's moving space. Number 5, the thing that drags space itself. Up to now, spin has been a thing that objects do. The planet turns, the star turns, the gas swirls. Fine, unsettling, but understandable. A spinning black hole breaks that, because a spinning black hole doesn't just turn inside space, it turns space. Take a black hole and set it rotating. Around it, something called frame dragging switches on. The black hole grips the fabric of space itself and winds it up, like a spoon dragged through honey, except the honey is the emptiness you're made of standing in. Space near a spinning black hole is not a stage that things move across. It's a whirlpool, and it's turning. Get close enough into a region called the ergosphere, and the dragging gets so strong that staying still becomes physically impossible. Not hard. Impossible. You could fire your engines with everything you have, aim them perfectly to hold your position against the distant stars, and space would still sweep you around the black hole like a leaf in a drain. There is no stationary there. The option has been deleted. You will co-rotate because the ground you're standing on, which is nothing, is itself in motion. And before you tell yourself that's some far-off exotic nightmare that doesn't touch you, here's the quiet horror. Frame dragging isn't unique to black holes. Anything that spins does it. Anything with mass and rotation twists the space around it, just a little. Which means Earth does it too. Our own planet, turning underneath you, is winding up the space around it by the tiniest amount. And we didn't just guess that. A NASA mission called Gravity Probe B flew gyroscopes in orbit and measured the twist. It found Earth dragging space-time by a whisper, a few tens of thousandths of a degree a year, exactly the amount Einstein's math predicted. So the ground you're standing on isn't only carrying you around at 1,000 miles an hour, it's slowly wringing out the space you live in, like a hand closing around a wet cloth. You can't feel that either. This is the moment spin stops being something that happens to stuff out there and becomes something woven into the emptiness everywhere, including right where you're sitting. It's not that objects spin through a calm, still space. There may be no calm, still space. Spin goes all the way down into the fabric itself. And if space can turn near one small planet and one dark hole, the obvious question is how big that can get. So let's stop looking at single objects. Let's look at the whole whirlpool you happen to live inside. Number 6, the whirlpool you live inside. You live in a whirlpool, a real one. It's just so slow and so enormous that you've never noticed you're going around the drain. The Milky Way, your galaxy, is spinning. Not metaphorically. Those beautiful curved arms in every picture you've ever seen are curved because the whole thing is turning. 100 billion stars wheeling around a bright, crowded center. And you're on one of those arms, way out in the suburbs, going along for the ride. How fast? The sun, with you on board, is orbiting the galactic center at about 230 kilometers every second. That's the 500,000 miles an hour from the very beginning. You are, at this exact moment, part of the spin of a galaxy. But the galaxy is so huge that even at that ludicrous speed, one lap takes forever. A single trip around the Milky Way takes roughly 230 million years. They call it a galactic year. And here's what that means. The last time the sun was sitting exactly where it is right now in its orbit, the first dinosaurs were just showing up on Earth. You're more than halfway through the galaxy's slow turn since the age of reptiles began, and you'll be long, long gone before it finishes this loop. That's the scale of the whirlpool you can't feel. A turn so vast it uses up entire auras of life on Earth as tick marks. And the galaxy's spin hides a secret. When astronomers measured how fast stars way out at the edge were going, they got a shock. The outer stars were moving too fast. Way too fast. At those speeds, with only the gravity we could see, the galaxy should be flying apart, flinging its own stars off into the dark like mud off a spinning tire. But it isn't. It's holding together. Which means something invisible is out there, gripping the galaxy, adding the gravity that keeps the fast spinning edge from escaping. We call that missing something dark matter, and we still don't know what it is. We only know the galaxy's spin gave it away. The turning revealed a ghost, so the whirlpool you live in isn't just big, it's spinning fast enough that its own rotation exposed one of the deepest mysteries in physics, a kind of matter we can't see, touch, or explain, wrapped around us in the dark. One galaxy, turning, hiding a monster. Fine. But galaxies aren't alone out there, and when you start watching how they line up with each other, the spin starts looking less like an accident and more like a plan. Number 7. Galaxies are spinning in step. Here's where the story stops behaving. Everything so far has a clean, local explanation. A cloud collapses, so it spins. A planet forms from swirling debris, so it turns. Every spin we've looked at was made right there, on the spot, by nearby gravity doing nearby things. Comforting, in a way, each spinner minding its own business. Then astronomers looked at quasars. Quasars are the blazing hearts of distant galaxies, powered by giant black holes. And each one has a spin axis, a direction it's turning, like the tilt of a top. There's no reason two quasars sitting billions of light years apart should agree on which way to point. They've never met. Light itself hasn't had time to cross between them since the universe began. They are, by every rule that should matter, total strangers. They're not pointing randomly. A team using one of the biggest telescopes on Earth studied 93 quasars strung across the sky in huge groups, and they found that the quasars' spin axes line up. Not perfectly, but far more than chance allows. Quasars billions of light years apart are tilted the same way, and they tend to point along the vast filaments of galaxies they're embedded in. The odds of that happening by accident came out below 1%. Sit with that. Objects so far apart they can never have communicated are turning in a coordinated way. Their spins are correlated across distances that make the word distance feel useless. Something lined them up. And nobody knows what. This is the turn. Up until now, you could tell yourself spin was a local habit, a thing that happens over and over in separate little pockets that never talk. But coordination across billions of light years isn't local. It can't be. There's no cloud big enough, no gravity fast enough to reach across that gap and comb all those spins into alignment. The scientists who found it said carefully that it might be pointing to a missing ingredient in our models of the universe. A missing ingredient. That's how researchers say, we have no idea and it scares us a little. So now you have a choice about how to feel. Either it's a coincidence stacked so high, it stops sounding like a coincidence. Or the spin we've been tracing this whole video from your body to your planet to your galaxy isn't a pile of separate accidents at all. Maybe it's all connected. Maybe it was all set turning by the same hand. And if that's true, then the spin should show up at the very largest scale there is, on structures so big that a whole galaxy is just a fleck of dust inside them. Number 8, the cosmic web is turning. Zoom out as far as it's possible to zoom, past stars, past galaxies, past clusters of galaxies. Keep going until galaxies themselves shrink to specks. At that scale, the universe isn't scattered evenly. It's stringy. Matter is strung together into gigantic threads, filaments of galaxies and gas stretching for hundreds of millions of light years, wrapped around vast empty voids. Astronomers call the whole tangled structure the cosmic web. It's the largest pattern that exists. For a long time, everyone assumed those threads just sat there. Enormous, sure, but static. Cosmic scaffolding, too big to do anything as lively as spin. In 2021, a team mapped the motion of galaxies inside these filaments. And they found the threads are rotating. The galaxies strung along them are corkscrewing around the filament's length. whole tendrils of the universe turning slowly in place. It was the largest rotation ever seen. Structures hundreds of millions of light years long, spinning. Then, more recently, another team found one of the biggest yet. A razor-thin string of galaxies over 100 million light years away, doing two things at once, each galaxy spinning on its own, and the entire thread rotating together, all of them going around like passengers on the world's slowest, largest carnival ride. One scientist compared it to a teacup's ride at a theme park, except the teacup is longer than you can picture, and every dot of light along it is a galaxy full of worlds. Here's why this one should stop you cold. For the spins we talked about earlier, we had explanations: collapse, local gravity, the skater rule. But nobody has a good theory for how you spin up something this big. Filaments this size shouldn't rotate. There's no obvious force that reaches across 100 million light years and sets a thread of galaxies turning. The researchers said, in plain terms, that it may point to unknown mechanisms of angular momentum generation. Unknown mechanisms. Something is making the biggest things in existence spin, and we do not know what it is, so follow the pattern with me. You spin, your planet spins, your solar system spins, your galaxy spins. Distant galaxies spin in step with each other. And now the largest strands of the entire cosmos are spinning too, on a scale where our physics runs out of answers. At every level you look, from a body in a chair to a thread of galaxies, the universe is turning. Which forces a question we've been circling this whole time. If everything is spinning all the way up, then where did the very first spin come from? Number 9. Where did the first spin come from? You've got a real problem now, and it's the rule from the start of the video that causes it. Spin can't be created out of nothing. It can only be moved or squeezed or handed off. The skater didn't invent her spin. She already had it and pulled it tight. The collapsing cloud didn't invent its spin. It inherited a whisper of rotation and crushed it into a scream. Every spinning thing got its turning from something that was already turning before it. So run the tape backward. Your spin came from Earth. Earth's spin came from the debris disk. The disk's spin came from the cloud. The cloud's spin came from the gas around it. Keep rewinding, further and further, and you arrive at the early universe. And the early universe was almost perfectly smooth, flat, even, a near featureless soup with no obvious swirl anywhere in it. A smooth, still beginning. A spinning everything now. How do you get from one to the other? The leading answer is gentle and a little beautiful. In the early universe, matter wasn't spread perfectly evenly, just almost. There were faint lumps, slightly denser patches here and there. And every young clump of matter had neighbors, other lumps sitting nearby. Those neighbors pulled on it with gravity, and because they were off to the sides rather than dead center, they didn't just pull it inward. They tugged it, torqued it, like grabbing the edge of a merry-go-round instead of the middle. Multiply that across billions of proto-galaxies, each one getting a slight gravitational twist from the lumps around it, and you see the entire universe with rotation. No master switch, no cosmic hand, just everything gently torquing its neighbors as gravity started pulling structure together. Scientists call it tidal torque, and remarkably, you can predict a lot of it just from the conditions at the very beginning. And here's the honest, important part. You do not need the universe itself to be spinning to explain any of this. Local tugs from local neighbors are enough. Things can spin in every direction all over the sky with no overall rotation of the whole. That's the standard picture, and it works. The spin was seeded from below, piece by piece, not poured in from above. That should settle it. That should be the end of the video. A tidy answer, everyone goes home. Except there's one door that picture leaves open, just a crack. And a small group of scientists have started to wonder what happens if you walk through it. Number 10. Is the whole universe spinning? Everything up to this line has been solid ground. Real physics, real measurements, real spinning things we've watched and mapped. Conservation of angular momentum is a law. Frame dragging was measured. The filaments really do rotate. All of that is as real as the chair you're in. What comes next is not settled. It's a question a few serious people are asking out loud, and I want you to hold it as a maybe, not a fact. The maybe is this. What if the reason everything spins all the way up and down the ladder is that the universe itself is turning? The idea isn't new. Back in 1949, the mathematician Kurt Gödel handed Einstein a birthday present, a solution to Einstein's own equations describing a universe that rotates as a whole. The math was airtight. General relativity, our best theory of space and time, flatly allows a spinning universe. It was never impossible. It was just assumed not to be the case because a rotating cosmos brings strange baggage, and it was cleaner to say the universe doesn't spin and move on. Then, in 2025, a team took the idea back off the shelf, because our cleanest picture of the universe has a crack in it. When scientists measure how fast the universe is expanding, they get two different answers depending on how they measure, and the two answers stubbornly refuse to agree. It's a real crisis, serious enough that people worry it could break cosmology. They call it the Hubble tension. And this team showed that if the universe is very slowly rotating, that tension eases. The disagreement softens. The numbers start to fit. How slowly? About one turn every 500 billion years. So slow it breaks no known law of physics, so slow you could never feel it or measure it directly. The universe is under 14 billion years old, which means since the beginning of time, it has completed less than 3% of a single rotation. Sit with that for a second. Not that the universe spins fast, that it might be turning so gently, so patiently, that the entire history of everything, every star, every world, every life, has happened inside the first sliver of one enormous turn. It's not proven. It might be wrong. The smooth local answer from a moment ago might be the whole story, and this might be nothing. But it lines up unsettlingly well with what you've just watched. A body spinning. A planet spinning. A star. A galaxy. A web of galaxies. All spinning. All the way up. Maybe they're separate accidents. Or maybe they're all being carried, every one of them, by something turning underneath everything. You've never been still. Nothing has. And it's starting to look like nothing ever was.